Okay, so today we're walking through some of the problems in Chapter 4S. This is the supplement to Chapter 4 on reliability. I want to walk through the section 4S2, Quantifying Reliability. So in this chapter we talk about three rules. The first is rule number one. If two or more events are independent and success is defined as the probability that all the events occur, then the probability of success is equal to the product of the probabilities of the events. So the example, you have two lamps. Lamp 1 has a 90% probability of working, and lamp 2 has an 80% probability of working. And the success of this overall system is defined as both of the lamps working. So to calculate this, you take the probability of lamp 1, the probability of lamp 2, and you multiply them together. So I'm going to say this equals that times that. So the probability of this system working is 72%. There's a 72% chance that both of these lamps will work. So on to rule 2. Rule 2 says if two events are independent and success is defined as the probability of at least one of the events occurring, the probability of success is equal to the probability of either one plus 1 minus the probability multiplied by the other probability. So let's talk through this. This is kind of confusing. In this example, we have two lamps, but you've got lamp 1 and then lamp 2 is a backup to lamp 1. So lamp 1 has a 90% chance of working. If it doesn't work though, lamp 2 will try to work and it has an 80% chance of working. So the success of this system is if either one of these work. Okay? So to calculate this, lamp 1 has we'll do it over here to kind of line it up here. Lamp 1 has a 90% chance of working. Okay? Lamp 2 has an 80% chance, but it only tries to work if lamp 1 doesn't work. So if lamp 1 is working 90% of the time, then lamp 2 is only going to try to work 10% of the time. So the way I did that, I took 1 minus 0.9. 1 minus 0.9. So there's only 10% of the time that lamp 2 will try to work. And if it does work, there's an 80, or if it does try to work, there's an 80% chance that it actually will work. So we take 0.1 times 0.8. So there's a 0.08 chance that lamp 2 is going to work. Then to get the probability of this whole system working, you add these together. 90% that's going to work, 0.08 that'll work. So the chance of this entire system working is 98%. So you've got lamp 1 had a 90% chance of working, lamp 2 80% chance as the backup. If this doesn't work, that will try to work. There's a 98% chance that this system will work and one of these lamps will turn on. Okay, rule 3. If two or more events are involved and success is defined as the probability that at least one of them will occur, the probability of success is 1 minus the probability of all failing. Okay, so in this system here, let me make this a little bit bigger. In this system, you have lamp 1, which is a 90% chance of working, lamp 2 is an 80% chance of working, and lamp 3 has a 70% chance of working. So lamp 1 is going to try to come on. If it doesn't, lamp 2 will try. If both of these fail, then lamp 3 will try. So rule 3 says that we can figure out the probability that all of them will fail and then take 1 minus that to calculate the probability of the system working. So let's start at the top. Lamp 3 has a 70% chance of working. So if it's a 70% chance that it's going to work, then the chance of it failing is 1 minus 70%, or 30%. So lamp 3 has a 70% chance that it's going to work, a 30% chance that it will fail. Lamp 2 has an 80% chance that it's going to work. So what is the probability that lamp 2 will fail? Well, it's 1 minus 80% or 20%. Lamp 1 has a 90% chance that it's going to work. So the probability of it failing is 1 minus 90% or 10%. Okay? So the probability that all of these are going to fail, so the probability that this whole system will fail, is done by multiplying those three numbers together. So this times this times this. So the probability of this system failing is 0.006 or 0.6%. So then what is the probability of this system succeeding? It is 1 minus that number. So the probability of this system succeeding is 99.4%. So let's do an example. So in this example, determine the reliability of the following system. Okay, so the reliability of this first one working is easy. It's 98%. This next one has a backup, doesn't it? So I'm going to move this down a little bit. So the second one, the first one here has a 90% chance of working. But if it doesn't work, which is 1 minus 0.9, then its backup has a 90% chance of working. I'm going to scoot that over. So its backup has a 90% chance of working. So the chance that the backup will fire and will actually work is this times this. So we add those two numbers together. Okay, so the probability of this first part working is 98%. The probability of this second part working is 99% because it's got a backup. And then finally the third part. So probability that will work is 95. The probability that its backup will work is 1 minus 0.95 times 0.92 is 0.046. You add those together, and it's 0.996. Okay? So then the probability that this entire system, well, let's walk through. So the probability that this first one is going to work is 98%. The probability that this one will work is 99%. The probability that this one will work is 0.996 or 99.6%. The probability that this whole system is going to work then is those three numbers multiplied together. This times this times this. So it's 96.63192% is the probability that this whole system is going to work. And that is a walk through rules 1, 2, and 3 on quantifying reliability.